Hello everybody, in this video we are going to continue the conversation about parent functions and vertical and horizontal translations. In the previous two videos we talked about linear functions and quadratic functions. In this video we are going to focus on an exponential parent function and exponential translations, both horizontal and vertical. So the parent function, or any function that has to do with the exponential family, is going to be in this form right here, where a and b represent numbers. They can be either positive, negative. They can also be fractions and decimals. But for the sake of what we're doing today, we're going to use this one right here as our parent function. So we're going to use y is equal to 2 to the x power. So our x is actually an exponent, so we're going to plug in numbers right there. So let's go ahead and create a table so we can create a graph, and then talk about some of the key features, and then do a quick reflection across the x-axis. Alright, so I have created a table of values here with x and y, and I know we normally use negative numbers, a 0, and positive numbers, but in order for us to avoid fractions, let's just stick to 0, 1, 2, and 3. So we're going to take these x values and plug it in as the exponent for that 2. So for this one, if you feel a little bit more comfortable, you can grab your calculator, just because there are some things that kind of come up that are out of the ordinary. So let's go ahead and grab our calculator, and let's do 2 raised. So I'm going to use this one right here, this button right here, to raise it to any power. So if you hit this one, it's going to automatically put the 2 there, but if you hit the one right next to it, it gives you a little box so you can enter whatever value you want. So for that one, we're going to start with 0. Anything raised to the 0 power is automatically 1. Doesn't matter what number it is, if you raise it to the 0 power, it's 1. Alright, 2 raised to the 1 power is 2. 2 raised to the 2nd power is 4. And then 2 raised to the 3rd power is 8, because that's 2 times 2 times 2. So let's go ahead and put 8 here. And you can do more numbers, but we're going to run out of space since we're trying to graph them on this coordinate plane. So let's take these points and let's create our graph. So 0, 1, 1 and 2, 2 and 4, and then 3 and 8. So if you're not familiar with an exponential function, you're going to realize that it has this curve, and it curves in either a positive or negative direction. Now when we go to the other side of the x-axis, the y-axis, I'm going to ask you to get really close and then just kind of ride along the x-axis. But do not cross the x-axis, because an exponential function actually has something called an asymptote, which is an invisible line or barrier that doesn't allow your graph to actually cross it. So for the parent function that we're using, that line is the x-axis. So I'm going to highlight this right here to remind you that that is an invisible line that your graph is not allowed to cross. It can get really close to it, but it's never going to touch it or cross it. So that is the line that we use to help guide us when we create our graph. Now, we're also going to create a reflection across the x-axis. So just like when we did for linear and quadratic, we're going to take these points that are here, and we're going to measure to see how far they are from the x-axis, and then replicate them on the opposite side. So let's start with this one right here. Notice that this point is 1 unit above the x-axis. Well, the reflection would be 1 unit below. This one is 2 units above, so we're going to use 2 units below. This one is 4 above, so 4 below. And then the last one was 8 units above the x-axis. We need to go ahead and make it 8 units below. And so we're keeping them on the same vertical lines, but we're doing them in the opposite direction. So when we get ready to do this, we're going to connect our dots and form a curve. And when we do this in the opposite direction, just get really close to the x-axis, but don't actually cross the x-axis. And because we created a whole different graph, we're going to give it a different name, which in this case is g of x. So we can say that g of x is just f of x, but reflected across the x-axis. Alright, so I went ahead and wrote the description right here that represents g of x compared to our parent function f of x. Alright, so let's see what we can do about exponential functions and translating them to the left or to the right. So I'm going to go ahead and look at this one right here. And in order for us to do these translations, we need to remember that we need points. So I'm going to use the same points that I used for my parent function. And I'm going to start with 0, 1, 1, 2, 2, 4. And it might not be necessary, but I'm going to go ahead and use 3 and 8. Okay? You can get away with just doing these 3 points, but I'm going to go ahead and add that extra one. I am going to remind you that because this line does not cross the x-axis and it kind of glides alongside it, that means that we have a horizontal asymptote at the x-axis. So it is going to be the lowest point of our graph. So we're going to translate this to the left. So let's go ahead and take each one of these points and let's move them 3 units to the left. And there's the first one. There's the second one. And then the last one. So we're just basically going to keep the same form. And so I'm going to connect these points, try to replicate that curve. And then when I go in the opposite direction, just remember that you're not to cross the x-axis like this. And so we can clearly see, and this one for this one, we're going to compare this point and this point. Okay, so since this one doesn't have an x-intercept, we're just going to kind of compare that y-intercept to where the other point is, either to the left or to the right of it. And then we can do the same thing to the right. So for this one, we're going to move 4 units to the right. 4 units to the right. And then the last one. And so anytime we move to the left or to the right, we're just going to use the same asymptote for this one. So that one actually doesn't change because the lowest point doesn't change. And so I'm going to circle this one right here so you can see that it was moved 4 units to the right. So I'm going to go ahead and write the description for this one. And then we're going to look at the vertical translations, which is going to have an added piece to it because of that horizontal asymptote. That one is actually going to change when we move it up and down. All right, so as you can see here, I went ahead and wrote in those descriptions for g of x and h of x, and we're comparing it to the parent function, which is our f of x. And we can see where it has been translated 3 units to the left and 4 units to the right. So the last one we're going to look at is this one right here. We're going to use those same points. So I'm going to go ahead and make them apparent here. That these are the points we're using. I'm going to go ahead and circle this one to remind you that that's the one that we're using to compare in what direction it moved and in how many units. All right, I'm going to highlight our horizontal asymptote, which is going to help guide us with the rest of our graphs. So for this one, we're going to take these points, but not just the points, we're also going to take the asymptote and we're going to shift it. So this is the only time where we change this line is when we go up and down, because that one goes with us, because it is considered the lowest point of the graph. So we're changing that as we're translating up and down. So for this one, we are going to move up 2 units. So we're going to take, I'm going to start with the asymptote. So if we're going to go up 2 units, I'm going to take this horizontal line and move it up 2 units. And so we're going to let that line guide us when we connect our dots. So from here, we're going to go up 2, 1, 2. I'm going to circle this one, up 2, up 2. And notice that this one was already on the edge of our graph. We don't have any room to go up 2 for that one. So we're going to use these 3 points here to connect our dots. We're going to call this G of X. Now, as I go in this direction, please remember that this line here, we cannot go below this line when we create our graph. So as soon as we get low enough to touch it, we're just going to kind of glide along with it. All right, so that's what we can see that's been translated 2 units up. This time we're going to go ahead and translate 3 units down. So before I start with my points, I'm going to take that horizontal line and move it 3 units down. And I find it very helpful to use that horizontal line to connect the dots. So that's where I start first. All right, so from here, let's go ahead and go down 3 units. 1, 2, 3. 2 and 3. 1, 2, 3. And then this one, 1, 2, 3. All right, I'm going to connect them on this side and call this H of X. And then when I come to this side right here, just let it glide. And I'm going to call this F of X. Alright, I'm going to circle my y-intercept, and I can see where this graph was moved 3 units down. So I'm going to go ahead and take the time to write out the description compared to the parent function. Alright, so as you can see, I went ahead and wrote in the descriptions. We can see that g of x is f of x, but it was translated 2 units up because we're comparing the y-intercept, and we can see that it is 2 units above the original parent function y-intercept. We can see that h of x is f of x, but it's translated down 3 units. And so when we compare those 2 y-intercepts, we can see that h of x is 3 units below the parent function. Okay? And we can also use our asymptotes to kind of see how far up and how far down our graph was moved. So I hope that these examples have helped, and so I will see you guys in the next videos.